Good evening. Good evening. Okay, let us start with one more thermal physics problem. This is a question today I asked in my class. Mixing different liquids, equal masses of water at 80 degrees centigrades and paraffin at 20 degrees centigrades. Two different liquids. Okay, one is 80 water, 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 and paraffin. The other one is paraffin. It says equal masses. So what I'm going to take is I'm going to take 100 grams of water and 100 grams of paraffin. Liquid paraffin. Okay. So liquid paraffin looks very much similar to that of water. So I'm going to take both of them. But the only problem is this is at a different temperature, this is at a different temperature. Are mixed in a container of negligible thermal capacity. So what I do is I take an insulator and then add about 100 grams of water and 100 grams of paraffin into it. The specific heat capacity of water is twice that of paraffin. What is the final temperature of the mixer? That's what is the question. So there were a few students who made this mistake. Who said that, sir, initially, anyway, this temperature is given, this temperature is given, 80 plus 20 divided by 2 will be 50. Okay, so first, can we apply this? Now, let me tell you a story. Let us say I'm teaching thermal physics in the classroom. There are two students, student A and student B. Student A is very intelligent. Okay, so of course, I'm teaching the topic for the first time, and he is also learning this topic for the first time. Okay, so both of them are learning the topic first time. So this guy is very intelligent. This guy, or I can say, the moment I teach the same one, both of them are sitting in the same bench, the same distance between him and me. Okay, when I teach it, he is able to answer the test properly. Okay, and he is not able to answer it properly. Or maybe I'm asking questions, but he responds very clearly and he is not at all responding. What could be the reason? As you rightly guessed, it could depend upon the grasping capability. For some students, it might be in such a way that the grasping capacity could be lower. Some of them may have a higher grasping capacity. That means you teach once, that immediately comes into the head. Some students, they need to write and see. That's why in the lower classes, we tell them you write and see. Okay. For some students like me, I always like to watch a video, then understand, and then practice it. Okay. Some people are something like video learners. So accordingly, there are 8 different types of learners. You would have observed some people will be scribbling something while teacher is teaching. They'll be drawing an image. But definitely that guy would have been learning something. Whatever he scribbles, that scribbling is nowhere related to what he is doing there. Definitely it is different. But still, somewhere that language, what the teacher is teaching, what he comprehends or what he understands, is the media here is nothing but a scribbling one. Some students have the habit of listening to music and then attempt the paper. Right? There are many ways which one can learn. So in a similar way, when you say that this is at a water and this is paraffin, the heat absorbing capacity of these two liquids could be different. And that is what you would have learned, something called as a specific heat capacity. Right? So if that is the case, now how do you do it? Now what we do is we say equal masses of water at 80 degree. So this is at a higher temperature, this is at a lower temperature. So this should be losing its temperature to paraffin. So what should we do? Let us say heat lost by water is nothing but MC water into delta T. What is delta T? I can write the final temperature of water. Let me take it as T. It is 80 minus T. 80 minus T. What is this now? Heat lost by water. Okay. Heat lost by water. I'll write it somewhere over here. I'll say this is, my pen is not writing properly. Heat lost by water. Okay. Now when this is losing some heat, the other person should gain that heat, right? Who is gaining here? Paraffin is gaining. So let me write heat gained by paraffin. So how should I write here? I should write MC paraffin multiplied by T minus 20. I'll write like this. Now these two should be equal. If they are equal, let me equate this. When I equate this, I'll write MCW into 80 minus T. Heat loss is equal to heat gain. It is something like I have 50 chocolates with me. Now 20 chocolates are given to my friend. Then he will have 20 and I will have 30. Such as some of them should be same. Or whatever I have lost, he has gained it, right? Now this should now be equal to MCP into T minus 20. When I equate this M goes away on both the sides. Now CW, what does it say? It says the specific heat capacity of water is twice that of paraffin. So I will write this as 2 times Cp into AT minus T is equal to Cp into T minus 20. So this Cp also goes away. Now what am I left out? Simplify this. 2 into AT is 160 minus 2T is equal to Sp T minus 20. Now take these terms, T terms on one side and the constants on the other side. So now this should be 160 plus 20 is equal to T plus 2T. Now T plus 2T should be equal to 3T and 160 plus 20 should be 180. This 180 should be equal to 3T. This implies T should be equal to 180 divided by 3, which should be equal to 60 degrees. Okay. So what is the right answer? Answer is D. So therefore, while you solve a problem, so don't go with the same notation or same notion that you had that averages will work. Okay. So this is a misconception. Many students do it. Of course, it appears to be silly for many of you, but still I feel that this is a very important thing to know, like why physics problems are tougher. It's not actually tougher. It's quite easier. But only thing is you should be able to split a problem into parts and then resolve it. If you don't split it and you just think like that, this is called as a dead leaves model in physics. So dead leaves model means something like you learned lots of physics. You have several leaves, which are dead leaves lying on it. On each leaf, there's an equation written. Now, the moment you see a problem, you just take up one of the leaves and say, hey, the equation of this leaf seems very similar to it, and I'm going to use this. Okay. So this is why most of them commit a mistake. So before solving a problem, try to understand the problem. 70% of your problem lies only in understanding. Okay. 20% or 10% is what it is solving. If you understand the problem, if you are able to split it into many parts, definitely nothing is difficult. You can easily resolve it. Thank you, friends, for watching this video. So like, share, and subscribe to my channel for more updates. It will also be easy for me if you can let me know what kind of problems would you like me to resolve. Thank you once again.